Next question number 131. A block of mass m is placed on a smooth inclined wedge ABC of inclination theta as shown in the figure. The wedge is given an acceleration a toward the right. The relation between a and theta for the block to remain stationary on the wedge is. Four options. Option 1, a equal to g cos theta. Option 2, a equal to g tan theta. Option 3, a equal to g by sin theta. Option 4 is a is equal to g upon cosecant theta. Four options. Okay. Now this is a wedge given. Let me draw a rough sketch. Okay, this is theta. Pseudo force will act this way. M is the mass of the block. Normal reaction is this way. You can resolve this into two components. Okay. If this is theta, this will be theta, vertically opposite angle, this will be theta. This is theta, this would be theta. These two are the intersecting lines. This is a vertically opposite angle. So this is n cos theta, this is n sin theta. Then the weight is acting vertically down. So n sin theta equal to ma. N cos theta equal to mg, because the block is to remain stationary. Divide, m will go, n will go, tan theta equal to a by g. Therefore a equal to g tan theta. This is theta, that will be theta. To show that only, I just drew two lines and I have explained. So weight is acting vertically down. Normal reaction resolve into two components. N cos theta will be balanced by mg and n sin theta will be equal to ma, because the block is to remain stationary according to the requirement of the problem. So the correct answer is option 2. Next question. A student measured the diameter of a small steel ball using a screw gauge of least count 0.001 centimeter. The main scale reading is 5 millimeter. And 0 of circular scale division coincides with 25 divisions above the reference level. If screw gauge has a zero error of minus 0.004 centimeter, the correct diameter of the ball is number 1 0.053 centimeter, 0.529 centimeter, 0.525 centimeter, 0.521 centimeter. See, this question is an experiment based one. It is an experiment based question. So final reading will be main scale reading or pitch scale reading or main scale reading, anything. Main scale reading plus circular scale coincidence into least count minus 0 error. So main scale reading 5 millimeter, but because the least count is expressed in 001 centimeter and all the answers are in centimeter, so convert this into centimeter. 0.5 centimeter plus coincidence being what is the coincidence? So this coincidence is given to be 25 into least count, so 0.025 centimeter. minus 0 error. So minus of minus 0.004. So this is 0.5, 0.025 minus and minus plus. So 0.004, 0.925 centimeter. Second option is correct. Next question. Question number 133. Unpolarized light is incident from air on a plane surface of material of refractive index mu. At a particular angle of incidence I, it is found that the reflected and refracted rays are perpendicular to each other. Which of the following options is correct for this situation? Option 1, I is equal to sine inverse of 1 by mu. Option 2, I is equal to tan inverse of 1 by mu. Option 3, reflected light is polarized with its electric vector perpendicular to the plane of incidence. Reflected light is polarized with its electric vector parallel to the plane of incidence. Okay. See, this question is related or based on what is known as Brewster's law. See, you have a plane surface. Unpolarized light. Okay. This light is unpolarized. So, represented like this. Unpolarized light. This is reflected ray. This is refracted ray. They are mutually perpendicular. This is refracted ray. This will be completely polarized. The electric field vector perpendicular to the plane. The dots indicate the vectors perpendicular to the plane of incidence. Plane of incidence you can consider to be the plane of the diagram here. Okay. So this is only completely polarized. Electric vectors being perpendicular to the plane of incidence, which is perpendicular to the plane of the diagram. Of course, this is the particular angle of incidence. That angle of incidence is known as Brewster angle or polarizing angle. Not given in the question, I am just telling. And also in that case you will have mu is equal to tan I. So I is equal to tan inverse of mu. But so don't get confused here. I is equal to tan inverse of mu not given. I is equal to tan inverse of 1 by mu is given. So this is not the correct answer. So what is the correct answer then? Reflected light is polarized with its electric vector perpendicular to the plane of incidence. Option 3 is correct. Next question. Question number 134. In Young's double slit experiment, the separation D between the slits is 2 mm. The wavelength lambda of light used is 5896 angstrom. And distance D, capital D, between the screen and the slits is 100 centimeter. It is found that the angular width of the fringes is 0.20 degrees. To increase the fringe angular width to 0.21 degrees with same lambda and capital D, the separation between the slits needs to be changed to, there are 4 options: 2.1 millimeter, 1.7 millimeter, 1.9 millimeter, 1.8 millimeter. Okay. So this is a problem related to angular width. Young's double slit experiment, angular width. You know angular width formula, lambda by D. So beta angular width. So you can say angular width lambda by D. So angular width lambda by D. First angular width 0.20 lambda 1 by D1. Second angular width 0.21 lambda same, so lambda by d1, lambda by d2. Lambda is same. You are supposed to find d2. So dividing one by the other, 0.20 by 0.21 is lambda will get cancelled. d2 by d1, we want d2. So d1 into, what is d1, which is 2 millimeter. I put d1 in millimeter, so I will get d2 also in millimeter. So 0.20 by 0.2, so 20 by 21. So 40 by 21. So this will be approximately 1.9 millimeter, because you put this d1 in millimeter, so d2 also in millimeter, it's a ratio. So the answer is option 3. Okay? Yes. Next question. An astronomical refracting telescope will have large angular magnification and high angular resolution when it has an objective lens of option 1, large focal length and large diameter, small focal length and small diameter, large focal length and small diameter, small focal length and large diameter. So we have to think about angular magnification, which is also known as magnifying power. We know it is FO by FE. And resolving power for a telescope, not for a microscope, d by 1.22 lambda. This is only called as angular resolution. This is called as angular magnification. You want both to be higher. So magnifying power to be higher means focal length of objective should be large. Diameter should also be large. So option 1 is the correct combination. Okay, thank you.